Welcome to the Nature of Light, What is a Photon presentation by Delta Group Engineering. I'll be taking you through the presentation, which you will see, is results-centric, rather than involving lengthy mathematical derivations. Of course, for those members of the audience which may be interested, full and complete derivations can be found at our website, www.deltagroupengineering.com, in PDF format. What are we going to cover? What is a photon, historically? Does it have mass and size? How do we calculate these from first principles? What else can we learn from its mass and size? What other particles can we determine the mass and size of, based on our photon method? What particle predictions have been experimentally verified to high precision by our photon method? And much more. What is a photon, historically? A photon is a massless packet of light, that's the standard definition. A photon behaves like a particle, it has momentum. Many photons behave as a wave and they can be represented mathematically as sinusoids, as the diagrams indicate. Does it have mass? Depending upon whom one talks to, it does. The particle data group estimates its mass energy threshold to be less than 6 by 10 to the minus 17 electron volts, based upon experimental observation and interpretation of the data. We calculate the mass energy threshold to be less than 5.75 by 10 to the minus 17 electron volts, that's within 4.3% of the particle data group figure. We obtain this result utilizing standard Fourier harmonics. Consequently, we calculate its mass energy to be less than or equal to 3.2 by 10 to the minus 45 electron volts. This is an extremely small quantity of mass, coming as no surprise, because the photon is considered to be massless. Does it have size? Yes, it has size. Why? Because quantum physics, the uncertainty principle and common sense dictates that zero anything isn't an engineering option for application. We calculate its diameter to be the Planck length. This calculation is in agreement with, and supports, quantum physics models. How did we calculate it from first principles? This can be achieved by 5 easy steps. Firstly, we apply dimensional analysis techniques, Buckingham's Spie theory and similarity principles to combine electricity, magnetism, and resultant electromagnetic acceleration. Secondly, we apply the equivalence principle to the pi groupings formulated. Thirdly, we apply Fourier harmonics to the equivalence principle. Next, we apply zero-point field theory to Fourier harmonics. Finally, we apply the polarizable vacuum model of gravity to the zero-point field. What else can we learn from its mass and size? To best answer this question, we need to consider the manner in which the mass was derived. The derivation process involved Fourier harmonics. Subsequently, the Euler-Mascheroni constant, also known as Euler's constant, is implicitly involved. It was first defined in 1735 and Euler stated that it was worthy of serious consideration. This constant is extremely important in mathematics and cuts across many areas, for instance, the Riemann's eta function. Physical verification of our photon mass energy equation suggests that gamma has a natural physical limit at a quantum level. The ramifications to science, that a mathematical constant can have a natural physical limit, is enormous, and cannot be overstated. What other particles can we determine the mass and size of, based on our photon method? All of them. As listed by the particle data group. It is said, a picture paints 1,000 words. If this is true, the picture painted by the breadth, depth and experimentally verified and implied accuracy of our results manifest an exciting canvas of new understanding. Our approach is based on the premise of regarding all fundamental particles as photon radiators. This facilitates the derivation and development of a method, not a theory, which produces the mass energy and radii of all fundamental particles. We have termed this method electrogravity magnetics. What particle predictions have been experimentally verified to high precision by our photon method? Basically, everything one can measure precisely is in agreement with our approach. For example, our method agrees precisely with the root mean square charge radius of the proton as determined by the Selleck's collaboration. It also generates the classical root mean square charge radius of the proton as defined by the National Institute of Standards and Technology. Moreover, it generates the electric and magnetic radii of the proton and the magnetic radius of the neutron as reported by Hammer and Meissner. Additionally, our photon method produces the neutron mean square charge radius as reported by Kamenov, and the top quark mass energy as determined by the D0 collaboration. Of particular importance are the references to large international experimental research efforts such as the D0, Selx and Zeus collaborations. It shall be demonstrated that we are able to achieve highly precise, experimentally verified results typically produced by billion-dollar facilities at international locations, utilizing the same method in all cases. What errors are associated with our photon method? EGM is the name we have assigned our photon method, and is an acronym for electrogravity magnetics. This table illustrates the EGM prediction for 1. The root mean square charge radius of the proton as determined by the Selx collaboration. 2. The electric and magnetic radii of the proton and the magnetic radius of the neutron as reported by Hammer and Meissner. 3. The classical root mean square charge radius of the proton as defined by the National Institute of Standards and Technology. 4. The neutron mean square charge radius as reported by Kamenov, and 5. The 2005 top quark mass energy value as determined by the D0 collaboration. As can be clearly seen from this table, the largest error associated with any prediction is less than 0.82%. If we consider experimental uncertainty, then the EGM predictions are in fact exact. It should also be noted that the standard model of particle physics is incapable of producing comparable results for as many particles as the EGM method. Predictions such as the photon mass energy threshold by the particle data group required adjustment of the theory to fit observation. Our method for calculating this value is purely mathematical, and did not require adjustment. What particle predictions are experimentally implied by our photon method? The root mean square charge radii of all quarks is generalized by the Zeus collaboration whilst satisfying all particle data group mass energy ranges. The mean square charge radii of all neutrinos, based upon experimental results by the Sudbury Neutrino Observatory, analyzed by Hirsch and Joshipura whilst satisfying all particle data group mass energy ranges. The root mean square charge radius of an electron from scattering experiments as reported by Milani. What is the mathematical pattern responsible? The specific equation that describes the mass energy and radius relationship between all particles may be written simply. Omega sub omega denotes the harmonic cutoff frequency. St sub omega is a harmonic value representing the ratio between two spectra. The equation shown illustrates that mass energy is simply distributed, but may take many forms, depending upon the value of St sub omega. What harmonic patterns form? This table contains a list of existing and theoretical particles. There are 3 columns marked with omega sub omega, each column represents a different particle. From left to right, they represent the proton, electron, and up quark. The black text denotes existing particles, whilst the red text denotes theoretical particles. By inspection of the harmonics involved in the up quark column, one can see immediately that the numbers 1, 2, 3, 4, 7, 8, 9, 10, all in black text, are an obvious harmonic pattern. The red text numbers, 5 and 6, represent theoretical quark core bosons that fill in those gaps. Applying the same principles to protons and electrons, very obvious harmonic patterns form. This table emphasizes the possible existence of 3 theoretical leptons and 2 theoretical quark core bosons. However, we believe that the 2 theoretical quark core bosons are in fact intermediate vector bosons, force carriers. This table illustrates clearly that all fundamental particles may be represented as harmonic multiples of any arbitrarily selected fundamental particle. If the electron is utilized as the reference particle, then we may state that all fundamental particles may be described in terms of photons. This point shall be covered again in a preceding slide. In the particle mass and size summary table illustrated, the EGM mass energy prediction for each particle agrees with the particle data group mass energy range. The 5 new particles predicted are not considered by the particle data group as they are not formulated via the standard model of particle physics. However, utilizing EGM we may predict, fairly precisely, the expected mass energy for each of the proposed theoretical particles. As can be seen, we would expect a particle to exist at 9 megaelectronvolts, 57 megaelectronvolts, 566 megaelectronvolts, 10 gigaelectronvolts and 22 gigaelectronvolts. What else does our photon method predict? 1. Pi, as a geometric ratio of fundamental particle root mean square charge radii, and 2. The fine structure constant utilizing the root mean square charge radii of the electron, proton, neutron, muon and tau particles with the exponential function according to the equations shown. Additionally, it shall be illustrated that the same approach used to quasi-unify particle physics in terms of mass energy and radii, also produces the Casimir force for a classical parallel plate experiment, in agreement with precise physical measurement. Our photon method also produces 3. The Casimir force, to within 0.01% of the classical parallel plate equation. Experimental verification has been determined to within 5% of the classical representation, and 4. Most importantly, our equation predicts different Casimir forces on different planets, the classical representation does not. Additionally, our photon method also produces 5. An experimentally implicit calculation of the Planck length based upon our experimentally verified particle calculations such as proton and neutron radii. This results in an increase in the Planck length by the cubed root of pi on 2, or approximately 16%, and 6. A gravity experiment, but that's a discussion for another day. So, what are the photon method summary points? 1. We have quasi-unified particle physics, by considering all particles to be photon radiators producing mass energy and radii predictions. 2. We have derived the Casimir force based on photons, and made new predictions, and 3. We have derived an experimentally implicit definition of the Planck scale based on photons. What does all this mean? 1. That photons are the quintessential particle from which all others may be described. 2. The gravitational spectrum is a simple, but extreme, extension of the electromagnetic spectrum. 3. There may be 5+ undiscovered particles based upon our harmonic interpretation of photons, and, above all, photonics is important. Well, I hope you've enjoyed the show. Please feel free to contact me by email or phone, the details are on the screen.